Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester is optoelectronics and optical communication, and the topic that I discuss today is very low loss materials and all plastic and polymer clad silica fiber. As far as low loss material is concerned, we require low loss material because what we want actually, we want to avoid the losses in optical fibers, right? So the main cause of loss in optical fiber is due to the material of fiber, or you may say the impurities in the fiber material. So in 1969, several scientists concluded that impurities in the fiber material cause the signal loss in the optical fiber. Means the impurities in the optical fiber is responsible for the signal loss. So if we remove these impurities in the optical fiber or the material of optical fiber, then we can able to reduce the losses. So it was possible to reduce the losses in optical fiber by removing the impurities. By removing the impurities, construction of low loss optical fiber was possible. So at that time, these impurities was removed from the optical fiber. So better results was come, and by removing the impurities, it is possible to have a low loss optical fiber. This is also true. The transmission of light along optical fiber depends not only on the nature of the light, but also on the structure of the optical fiber. This is also true because the structure of the optical fiber decides the transmission of light. Actually, the material that we used in manufacturing of optical fiber is high quality glass, which we represent this high quality glass by a chemical formula SiO2. So SiO2 means it's represent a glass. So we use very high quality of glass for the manufacture of this optical fiber. And why we use this glass material? Why we choose? The question is why we choose glass material? Why we choose glass material? Why this glass material is suitable in the manufacturing of this optical fiber? The answer is that it has low impurities. That's why we prefer glass-based optical fiber. So this glass SiO2 contains very low amount of impurities, such as water or elements other than silica and oxygen. And in previous lecture, we see that OH ions is responsible for external impurities, right? That's why very low amount of water are there in silicon-based glass. Using high quality glass produces fiber with low losses. This is also true. If you use high quality of glass, then the loss are very low. A small amount of some elements other than silica and oxygen are added to the glass material to change its index of refraction. Actually, certain external elements are also mixed in the optical fiber, because what we want actually, we have two regions in optical fiber. One is cladding region, other is core region, and the refractive index of these two should be different. This is that particular thing is desired for the proper propagation of optical light through this optical fiber. So we need two refractive index within the optical fiber. That's why some external elements are also mixed to change the refractive index of core as well as cladding. So each single mode or multi-mode step index or gradient index, glass or plastic, or large or small core fibers has an intended applications. So the system designer must choose an appropriate fiber design that optimizes system performance in the application. So the optical designers choose such a appropriate fiber design that optimize system performance in the optical fiber applications. Now we have a fiber which we called as a plastic clad silica based fiber, or you may say plastic clad silica fiber. So in telecommunications and fiber optics, a plastic clad silica fiber or polymer clad silica fiber, which we in short we say PCS, is an optical fiber that has a silica based core and a plastic cladding. And the cladding of a PCS fiber should not be confused with the polymer overcoat of a conventional all silica fiber. So this plastic silica fiber, which we call as a PCS fiber, in general have significantly lower performance characteristics, particularly higher transmission losses and lower bandwidth than all glass fiber. So uh, this PCS has some drawbacks as compared to pure glass based fiber that we already discussed. The main application of plastic clad silica fiber are industrial, medical or sensing applications where cores that are larger than those used in standard data communication fibers are advantages. But one of the main advantage of using that fiber is that the core diameter are large as compared to normal optical fiber. Then come to plastic clad silica fiber, and if you look at the picture, we have a middle region which we call as a core. This is pure fused silica. Then a middle region which we call as a cladding silicon, and outer surface is a jacket. Jacket protects cladding as well as a core. So the features of this particular plastic clad silica fiber is cost effective alternatives to all silica fibers. This is one of the reason. This is one of the feature. Better transmission than hard clad silica fibers. Ultraviolet and NIR types available in this plastic clad silica fiber. Higher numerical aperture. The numerical aperture of this particular fiber is higher, obviously because the core diameter is also higher. So the light gathering property of that type of fibers are higher because of high diameter of the core or high numerical aperture. Biocompatible materials, then core diameter up to 2 mm, right, and high concentricity. So these are some features of this plastic clad silica fiber. Then its property, plastic clad silica fiber properties. Number one, step index profile, means the profile is a step index, or you may say step index fiber. Step fiber has step index profile. So this particular fiber come in the category of step index. Numerical aperture is 0.37, minimum band radius, and laser damage threshold. So these are some properties of that particular fiber. The structure remains the same. Core region have a pure fused silica, middle region has a cladding, and outer is a jacket. Then some application of this plastic clad silica fibers. Number one application is medical, then laser surgery, then angioplasty, then spectroscopy, then remote sensing, then laser diode coupling, and laser beam delivery. So these are some application of this plastic clad silica fiber, and that's all. Thanks. So it is something, this particular topic is just theoretical. The student should go through the books, read this particular optical fibers, make a short notes, and just write the things, right? So this is much theoretical actually. Nothing a new concept involved in this particular topic. So thank you very much.